Okay, let's talk about one of the most common and honestly frustrating mysteries in networking. You've set up a bonded network link, right? You're expecting this massive speed boost, but your transfers are still just crawling along at the speed of a single connection. So what on earth is going on?
Here's the classic scenario. You've got two 10 gigabit links, you bond them together and you're thinking, awesome, 20 gigs of throughput, here I come. But then, in reality, you kick off a big file transfer and you're stuck, totally bottlenecked at 10 gigs. You look closer and you see one link is doing 100% of the work, while the other is just sitting there, completely idle. It's the ultimate expectation versus reality problem.
So why the huge mismatch? Well, it all comes down to a fundamental misunderstanding of how LACP actually works. See, it's not about just splitting your traffic 50-50. It's about a much smarter but also more specific process called hashing.
And this is the core idea right here. LACP doesn't just randomly chop up your data and spray it across the links. No, it's much more intelligent. It looks at the address information inside your packets to keep an entire conversation, what we call a flow, together on one single physical line.
The process itself is actually pretty elegant. First, the system grabs the packet headers, the source and destination IPs and ports. Second, it crunches those numbers through a formula to get a unique hash value. And third, that hash value determines which single physical link that entire flow will use. Every single packet from that same conversation gets the same hash and goes down the same pipe.
Which, of course, brings us to the million-dollar question. If this system is built to distribute traffic, why does it so often feel totally unbalanced, with everything getting jammed onto the same single link? And the answer is the single flow bottleneck. Any single TCP connection, think about it, one big file transfer with SCP, a download using curl, or a massive database query is treated as just one flow. And since every packet in that flow has the same source and destination info, they all get the same exact hash. That means they're all pinned to the same physical link, leaving your other links with nothing to do.
But what if you have lots of flows and you still only see one link being used? Well, in that case, the problem might not be the hashing logic at all. It could be something way more basic, a broken bond caused by a simple misconfiguration.
The secret to diagnosing this is a little piece of information called the aggregator ID. If the IDs for the different links in your bond don't match up, that's a dead giveaway. It's basically a giant red flag telling you there's a problem with your physical cables or, more likely, your switch configuration.
And you can see this for yourself when you check your bond status. In a perfect, healthy setup, both of your physical interfaces will share the exact same aggregator ID. But if you see two different numbers, like in that broken config column, that means the switch doesn't see them as a team. Only one link gets to join the bond, and you need to get your network admin to fix the switch side of things.
So, how do we get the performance we were promised in the first place? Well, the solution isn't about making one single connection faster. It's about enabling many connections to run fast all at the same time.
To really get LACP to work for you, you've got to follow this checklist. First, and this is the most important one, your applications have to use multiple parallel connections. You have to create multiple flows. Second, you have to make sure the switch is configured right. Remember that aggregator ID? Third, all your links need to be running at the same speed in duplex. And finally, use a good hashing policy, specifically Layer 3 plus Layer 4, which uses both IPs and ports to get the best possible traffic spread.
So if you remember one thing, make it this. You have to stop thinking of LACP as a speed multiplier for a single task. It just isn't. What LACP really is a powerful and very smart load balancer that's designed to handle many different flows all at once. And that leaves us with a practical question, doesn't it? Knowing now that LACP is built to balance distinct flows, not just individual packets, how might you change the way you design your applications or move your data to finally take full advantage of all that bandwidth you have just sitting there, waiting to be used?